Firstly, we need to create a new alignment. Make sure to select the DNA as the types. Once that's done, you will see a sequence window pop up. We can just delete it. Next, we insert our actual sequences from the file where we save our raw data, which is dataset 3. Once that loads, you will see the sequences appear on the screen. To make things easier to read, we will enable the cluster W color option. This way, each base gets its own color and its match is clear to compare. Okay, so now we need to carefully check each sequence for any empty gaps. This can affect the accuracy of our trees, so it's important to clean them up. Once everything looks good, don't forget to align the sequences. This helps us clearly see the genetic differences between species. To do this, we go to Data, then click the Export Alignment, choose FASTA format, and save the file. From there, we use the Save dataset. But this time, instead of clicking on DNA sequence, we choose the nucleotide sequence option. You will see a table pop up. So, at the top, it automatically selects the best model for us based on the data. Okay, so for the next part, building the phylogenetic tree itself. Just stick with the default settings based on what we have selected earlier. Make sure all the informations are correct. Once the tree is generated, go ahead and save it as PDF file or PNG file. And that's it. The next step is to interpret the tree and start answering the analysis questions.
This is the phylogenetic tree of dataset 1. We have scar bar of 0.01 per bar is the number of substitution per site, which means the longer the distance, the higher the sequence divergence. From tree, we can see the species 2 bracket 2 and species 2 bracket 11 6 are sister species because they share the common ancestor. Species 2 bracket 2 8 and species 2 bracket 7 15 also sister taxa. This is because they share most recent common ancestor. The species is close relative. The species 2 bracket 16 1 share more distant common ancestor with species 2 bracket 2 8 and species 2 bracket 7 15. Species 2 species 2 bracket 11 6 species 2 bracket 16 1 species 2 bracket 2 8 and species 2 bracket 7 15 share a deeper common ancestor other than species 2 bracket 4 10. Species 2 bracket 3 11 species 2 bracket 14 5 species 2 bracket 5 17 and species 2 bracket 17 true show our sister taxa because they share recurrent common ancestor. Species 2 bracket 6 16 species 2 bracket 15 4 and also species 2 bracket 13 7 form one clade due to their share ancestor and close genetic similarity. Species 2 bracket 12 9 and species 3 form another clade with no evolutionary distance observed between them. The species show suggesting very high genetic similarity. This means they likely share a recurrent common ancestor and have almost identical DNA. Species 2 bracket 10 14 and species 2 bracket 9 13 are sister taxa because very close genetically and common ancestor in closer evolutionary time. Last but not least, species 2 bracket 8 12 isolated from either branches and undergo the most genetic change. The species are categorized as outgroup.
Which taxa indicate the most genetic change? Based on the phylogenetic tree analysis, the taxon species 2 subgroup 8 sample 12 show the longest branch length from the root, which signifies that it has experienced the greatest amount of genetic divergence over time compared to the other taxa in the tree. This attained branch length reflects a higher number of evolutionary changes such as nucleotide substitution, indicating that species 2 subgroup 8 sample 12 has accumulated the most genetic difference from the last common ancestor, making it the most genetically distinct among the taxa analyzed.
Based on the phylogenetic tree analysis, several taxa exhibit close genetic relationship. The most closely related pair is sp211.6 and sp216.1, which share a very recent common ancestor indicating strong similarity. Similarly, sp21014 and sp2913 form a distinct pair, showing they are more closely related to each other than to any other taxa in the tree. Another close relationship is observed between sp2410 and sp2311, which are located on the same branch, suggesting a shared evolutionary background. Likewise, sp2517 and sp2172 are closely related, supported by their connection through a recent common node. A small cluster comprising sp2137, sp2154, and sp2129 indicates moderate genetic similarity within this subgroup. Additionally, a larger clade that includes sp2z, sp228, sp2715, and a few others reflects a group of moderately related taxa that likely share a broader common ancestor. Notably, sp2812 appears on a long, separate branch, signifying it is the most genetically distant from all other taxa in the tree. This suggests a greater evolutionary divergence and possibly unique characteristics compared to the rest. In conclusion, the tree reveals varying degrees of relatedness from very close pairs to distinct outliers, providing insights into the genetic relationships among the taxa analyzed.
In our phylogenetic tree, the outgroup is sp2812. We can tell it's the outgroup because it branches off first, right at the base of the tree. That means it's the least related to the another taxa in our dataset. Outgroups are important because they help us root the tree and show the direction of evolution. So, in this case, sp2812X is a reference point for the comparing the rest of the taxa.